This is the second part for honors physics for an examination of how charges are affected by electric fields. But instead of the question being, how does the field push the charges, it instead is asking for you to identify what kind of acceleration does the charge experience because of that field, right? So it's the acceleration of a test charge that we are going to be dropping in. So let's do a quick review. We know that forces and accelerations are related to each other. Back in Newton's laws of motion, we found out that whatever direction the force is, that's a vector quantity, it will be the same direction as the acceleration, or vice versa, the acceleration is the same direction as the force. If the velocity and the acceleration, now let's think about other quantities that we should know that describe motion. Velocity and acceleration, how fast you're going, versus acceleration, which is how fast you're changing your velocity. If those two vectors are in the same direction, they tend to speed up. So remember what we used to talk about. If you're moving to the right and you experience a right-directed acceleration, then you're going to get faster. If you're moving to the right and your acceleration is to the left, a negative acceleration, they're in the opposite direction, well, you tend to slow down. So if they're in the same direction, you speed up. And if you're in the opposite direction, that is the velocity and the acceleration, you slow down. What happens if the force is perpendicular to the velocity? And that means kind of like, the force is to the right, but the velocity is upward, perpendicular. Here's an example. We have a force upward, but we have an object that's moving perpendicular to it. So here's a positive charge. Its velocity is to the left, but we know that it's going to be pushed toward the top of the page or upward. Well, what tends to happen is that the charge will curve in the direction of the force. So it turns them. The charge changes direction or turns. So how many different ways can you turn? Well, you can turn up, you can turn down toward the bottom of the page, you can turn right or turn left. And so we're going to take a look at a couple of examples and then see if you can't finish. So there's an electric field pointed to the right. So there's a source charge and there's an E field. And I draw these. Every time I take words and I put them into a picture, a positive charge is moving to the right in that field. So that's a test charge. So we're going to draw it smaller. And it's got a velocity to the right. It's moving to the right. So we know its velocity is to the right. Can you tell me what happens to its motion? Well, the first thing you have to ask yourself is, what do positive charges do in an E field? Well, they are pushed. And positives go with the E field. So that means parallel to the E field. So that means that positive charge is experiencing a force to the right and therefore an acceleration to the right. And eventually you'll get the hang of this and you won't have to draw it all out. It'll just make obvious sense. But what happens to an object whose velocity is to the right, who experiences a force to the right because of the E field, and therefore an acceleration in the same direction? And the answer is, right, a V that's positive and an A that's positive. That's an example of a charge that would speed up. Now let's do a second one. Let's talk about an electric field that's pointing upward toward the top of the page. And a positive charge is moving to the right, and it's crossing. So its velocity is crossing the E field, and that's okay. But we know that positives get pushed in the directions of E fields. So what would happen to this positive charge? It would get pushed in the upward direction. That's the direction of its force. So therefore, it would also accelerate in that direction. So what happens when you have an acceleration that's perpendicular to a velocity is, instead of speeding up or slowing down, this positive charge is going to keep moving to the right, but it's going to turn up. It's going to turn toward the top of the page. That's kind of something that you need to kind of get the hang of seeing. It's moving to the right. Its inertia is toward the right, but because the acceleration is upward, it's going to bend and curve its path. It's going to turn up toward the top of the page. One more, the electric field is pointing left. A negative charge is moving to the right,